Number 11 then, from paper 2 of the 2019 National 5. There's a triangle. As soon as you see that, you think of Pythagoras, but there's no right angle mentioned here. What does it say? It's a course for a jet ski race. The markers, etc. Gives the lengths. But the important thing it says is C is due north of B. And you have to determine whether B is due east of E. In other words, if that's due north and that's due east, that would have to be a right angle. Is this a right angle is the question. So that's a converse of Pythagoras. That means you just need to check the squares of the sides. The potential hypotenuse is the square of that equal to the sum of the squares of the other two sides. But what is this side? You'll need to work that out. It tells you the total length of the course is 1500. So that'll be 1500 minus the sum of those two. Well, that's 1250. Take that away and that's 250. Let's mark that in. 250 metres. Now you can check if it's right angled. So, AC squared, the potential hypotenuse, 650 squared. Pop it into your calculator, but that should be 6 sevens are 422500. Just double checking. That's one of those ones, the pattern for a 2-digit number ending in a 5 when you square it. Always ends in 25, and then whatever the digit is in front, you multiply it by the following number. AB squared plus BC squared. Well, that's 600 squared plus 250 squared. So that's 36000. We don't need to do that part. I've done it now. Plus 62500. So altogether you're going to have 0, 0, and there's a 25, a 42. It's the same thing. But you shouldn't just do that on the spot. You should just type that into your calculator to get that final result. Now you can make the statement. AC squared was in fact equal to AB squared plus BC squared. You can also write that number equals that number, but since they've got names, I can write this instead. Which means by the converse of, and it doesn't matter how you spell it, Pythagoras. Well, it does matter how you spell it, but you're not going to be penalised if you spell it a funny way. By the converse of Pythagoras, triangle ABC is right angled at B, which means B is due east of A. Number 12 then, similar shapes. You see it straight away there. You've got these two sectors here, and it says the sectors are mathematically similar. Well, circles are always mathematically similar, so if that's the case, that means these angles are the same. The area of the larger sector is 2750 square centimetres, and it shows the two radii there. This one's 50 and that one's 30. From that information, calculate the area of this smaller sector DEF. Well, the first thing to get is the ratio. What's the linear ratio? Well, the corresponding parts is this radius with that radius, which is 50 to 30. Cancel that down. Simplify it to 5 to 3. However, since it's an area working out, you need the area ratio. And areas are made from a length times a length. So if those are the ratios of the lengths, the area ratio will be the squares of those. So the area ratio is 25 to 9. Now that you know that, you can go ahead and work out this. Area of DEF, well, it's smaller than that, so it'll be the 9 over the 25 times 2750. You could pop in your calculator, but look, 275, 2 and 5 makes 7. That's 11 times 25, so 9 11s are 99, so it's 990 centimetres squared. Part B. Calculate the size of angle ACB. Well, that's fractions of a circle. All the fractions, all the turning fractions are the same in a circle. Whatever fraction that area is of the total area, and you know that because you know the radius, will be the same fraction that this angle is of the total angle, and you know that is always 360. So, the angle will be whatever fraction of 360 degrees, and that fraction is 2750 over the area of the circle, pi r squared. Pi times, and the radius is 50, so pi times 50 squared. Pop that in your calculator, and when you press the button you get 126.050 and so on. So I'll put that down as 126.1 degrees for angle ACB.